technical session 6, which is the last technical session in 2 days workshop. This session is going to be chaired by Dr. P.S. Pandey, ADG, EPNHS Education, ICAR, and rapporteur will be Dr. Alka Arora, ICAR, IASRI. There will be 2 presentations in this technical session. First from Mr. Satyajit Dwivedi, SAS, New Delhi. He'll be talking on IoT and AI in agriculture capabilities and applications. And the second presentation is from Mr. Karunesh Arora. He'll be talking on natural language processing in agriculture, scenario and challenges. This will be followed by the discussion. So I would request Dr. Pandey to chair the session.
Kindly give a copy of the program. Okay, very good afternoon to all of you friends. Already you are listening from yesterday itself, and what I could see, we are going in a very right track, and I hope that this session will be certainly going to be benefited for all of us. And with this, now I request Dr. Satyajit Dwivedi, SAS, New Delhi. Please. So we have 1.5 hours for the entire this session from 2 to 3:30, and so I request you to restrict your presentation by 20 minutes. 20 minutes is 2 presentation we have, and then further we will have the discussion. So with this, you can start this.
Thank you very much. Good afternoon, everyone. It's a very heavy topic, specifically after lunch, but I think it's a very exciting topic by itself. So I think I would be able to hold your attention to that. And, you know, amongst you, I always feel like a student. And I was thinking, what's the closest that could be for this kind of data science? And I went back to my school days and our school days when we used to prepare for our exam, and we used to solve multiple questions in anticipation of what will come in the exam. That is from the textbooks. Then we used to solve unit tests, seeing our knowledge, how much you have learned. Then we used to solve sample papers of exams. And then we used to apply the exam, and then we either pass or fail or excel or various things. If you look at it, you were training yourself of different types of questions that will come, different varieties of questions that will come. You were testing it in your unit tests and your model and sample papers, validating it, and then finally you were deploying it in your class. The same thing revolves around this subject, and things have become much more complex, much more sophisticated, much more advanced to that setup. And from human learning that we were doing in class, now we have gone ahead and looking at machine learning, because our compute power is at question. Our capabilities are at question. But fundamentally, it is you who we all are building these algorithms, we all are building this machine learning and deep learning. So I always start this thing that, although we talk about artificial intelligence and machine learning, the natural intelligence should not be forgotten in this realm. And over-dependence on machine learnings and all those things should also be curbed a bit, because this is coming from our expertise, our engagement in this kind of setup. But one thing I start also by saying that this is a very interesting book if you want to really look at it, how it is proliferating into this. Data is a MIT professor, physics professor, who has released this book. And any definitions, demystifying of it and understanding, this book will go a lot of way in clarifying some of the stuffs, and I borrow some of the thinking from Max as well. So why we are going into this space, why IoT and AI and machine learning is becoming more and more relevant is that the traditional analytics life cycle which was there from data to storage and extracting and then modeling and then doing your decisioning is not enough anymore. It's not enough to do that because you have now real-time information coming in, sensors are coming in, videos are coming in, drones are throwing data. There's whole amount of information flow that is happening in the system. So this traditional analytics life cycle has a gap, and that's why it needs to be looked at it from that standpoint. Then there are many definitions of artificial intelligence that has come up. People use AI, people use ML, people use deep learning within AI. I mean, they say AI is not required, does not require data and all. These are needs to be demystified. I consider these as a part of the growth or hype cycle when people are trying to position, trying to explore more and finding a meaning to all these topics and application around that. These kind of blur occurs. And this is sometimes we are also responsible for that as vendors. We clear that blur and then we demystify it and then we see the application of it and we remove. But the best definition that you can look at it is the science of training systems to emulate human tasks through learning and automation. Is this something new for us? Is a question that you need to ask. Is this something new? Haven't you been doing these things with a little bit of more sophistication, new learnings, new algorithms that has come in place? That's what is all about understanding this setup. We need to simplify our processes. We need to understand it from that point of view, that we have been doing these things for quite a long time. And that's where I would look at it, that the evolution, somebody mentioned that it's not only neural network in the previous session. I think that's very correct. It's not only neural network, but the genesis of artificial intelligence started in neural network. That's why we are carrying that legacy. And there has been many more things that has happened over a period of time that we have been looking at. And machine learning had started in 1980s and 2010, and deep learning and cognitive systems have now started making much more meaning because of certain reasons. And we have been there as a company, we have been there throughout, from 1970 onwards, 50 onwards, we have been doing this kind of a setup. But it's important to understand this aspect of it. Which is a superset, which is a subset, and which is a subset of what? Now, artificial intelligence is a completely process-driven. That is where it includes delivery. Somebody was talking about delivery also is important, which is absolutely correct. Delivery is important, data is important, quality is important. But the subset that you need to look at it is the artificial intelligence is the main superset. Machine learning is a subset of that, and deep learning is a subset of machine learning. So when we look at all these concepts, we need to look at from this standpoint, and all of these AI, ML, DL, whatever you refer to, require data. It could be big, it could be medium, it could be small, because these days, big data or medium data or small data, you cannot define it. Today we are doing big video analytics on very small data, which is pertaining to 10 CCTV cameras, and it has got 50 frames per second, and 50 frames per second, if you want to identify object itself is big if you want to train it for 10 days. Huge amount of information. It explodes when you look at it. So let us simplify the fact that you will require data for building this kind of capability. So all of them require big data or medium or small. And deep learning became relevant now because of the availability of large data sets. Now, I heard there were a lot of discussions on feature extraction, and deep learning is a topic that came up because we have to avoid certain feature extractions, because feature extractions sometimes becomes very, very domain centric, very, very individual centric. And it requires a lot of time, it requires a lot of pre-processing capabilities. So if I can shorten that from the data that is existingly available, then I will be able to do much more complex models. I would be able to put better algorithms, and that will lead to your deep learning setup. So this is something that is very, very important from a point of view that where is deep learning sitting up in the overall AI and ML standpoint. So we need to appreciate this part. Also the fact that we need to distinguish the capabilities of AI and the applications of AI. Sometimes people confuse between, advisory systems versus actual techniques that, do classification per se. So we need to little bit rearrange this thinking that there are very clearly distinct capabilities that we need to look at under artificial intelligence, and there are certain applications of artificial intelligence when you looked at. So these are some things that we need to see, that the chatbots, the conversational systems, the smart Q&A systems, the search systems, the robo-advisor, the facial recognition, all are a part of an application of AI techniques. But the capabilities that they require are ML, deep learning, self-learning reinforcement algorithm, and also natural language processing, because it requires NLI and NLPs of all that, NLGs of all that, to be able to NLUs and analyze and to interpret these things. So there are distinct capabilities that we need to identify as the applications and chatbots. The other thing that we are seeing is that the need or emphasis of AI and ML will not reside only at your enterprise or your data center in ICAR or in ISRI or any place. AI will see the need of deploying this where the data is getting generated. And we will see some of the use cases. There are many use cases that we are doing where you need to apply this ML and AI right at the place where the data is getting generated. When I say data, it means structured data, unstructured data, video data, image data, wherever it is. Wherever you are putting up that source, because there is no luxury today that you bring all the information over the cloud or set up communication mechanism to your data center, run your analytical model, classify it, and then take it back to the decision. That luxury in many of the use cases is not there. Some use cases still has that luxury. In some use cases, it is not there. So you cannot have this, and this has to coexist. These things has to coexist. Now, when I'm telling that it moves from this enterprise to the place where it is located, it is easily done in a PowerPoint, but it needs a governance mechanism. It needs a governance mechanism that I will build a model, I will deploy that model from here. I should be able to deploy that model on the gateways, and then I should be able to update that model also, manage the model and improve it, or add multiple models, because image classification, if you look at it, may pertain to different diseases. There are various crops, there are various diseases. Now, if I want to set up an infrastructure where I'm getting the images of all these, leaves or whatever that you are talking about, and classify what diseases are there, then I have to be spontaneous in responding to that, then it has to be deployed in this way. Now, when we combine these two, we see the gap that is getting filled up by this model. Now streaming data needs to be, pardoned for the format that is there, this is because of resolution part of it, but this is the setup that it is coming up to be, that real-time data models needs to be built up, but you will keep building it here, but you have an option of deploying it at the data center or deploying at the devices as well, the cameras itself, the servers that you are putting it at the local setup also, that will provide the intelligence there, and only the intelligence will flow into your data center, but the processing will happen locally. And I heard that there is a comment that we should not, computing power is a bottleneck in the previous thing, so we should not be filtering data per images and all. I don't agree to that. Because today gateways are having form factors, we can have 64 CPUs, 128 CPUs, large amount of compute power is available at a very cheaper cost. So we should not miss any amount of data, and if data quality is an issue, which I will show it, if data quality is an issue, then there are techniques in AI which handles it, like occlusion detection, occlusion handling. There are techniques that are there. We cannot say that just because data quality is bad, out of the 50 frames, I will select the 49th frame and take it for analysis. No, because that is the practicality that you need to do, because if I remove that, I will start getting problems associated with my classification that I need to do, because I need to treat as it is. So what is transferring here now is that the way the analytics is shaping up is that AI will be applied, mostly modeled, development will happen, innovation will happen at the data center or at your premises that you have seen. But some of them will flow back to the gateways or the concentrators or the edge devices or the cameras or the that you are detecting, and we are seeing that more and more that is happening. Your decisioning system will become a command and control, or your which will fuel innovation. That is how it is. And the automated response, I heard one of the statements was advisory statement. I think Professor Bedi, you mentioned about the advisory statement, if I remember it correctly. But that's exactly what it is. The automated response has got 3 classifications for that today. One is where, and Professor Reddy had mentioned, you should not bring out the human loop. When you do not want to bring out the human loop, then it becomes an advisory system. So that's a response that you need to give. But when you want to make it into a robot or a chatbot, or embed the natural language into with the subsequent session, probably should cover that, will become a conversation system. It is conversation based. You can engage into a conversation. The third thing is control integration. I will show you some example of control integration in smart irrigation that we are doing in Netherlands, and how we are handling these systems. So this is the landscape that organizations today are mastering it, because this seems to be an end for them as far as the analytics life cycle. This seems to be an end today. We thought that traditional analytics life cycle was an end 10 years back, but now we discovered that it is not the end. But this seems to be an end. I don't guarantee it. 5 years down the line, there might be many other things that will come up as trees or structures to it. But this seems to be an end, and therefore all the organizations are looking at an edge to enterprise analytics for IoT platform that will be powered by AI and machine learning. So this is the end state that organizations are looking at, and realign everything. So how does it flow? It flows from your data. You have agriculture applications. You have real-time data that is coming in, maybe canals, maybe vegetation, maybe fields, maybe pesticide spraying. Machines are real-time monitored now. Soil moisture, condition, humidity, tractors, you can fit CAN buses, you can get whole amount of data coming from crops production. And this will combine with through a gateways. So you need to establish gateways. If you are looking at village or if you are looking at district, these gateways need to be established that will collect all this information. Streaming analytics will be deployed here, and then data will flow into a persistent big data platform. And that big data platform could be in distributed environment, could be depending upon the use cases as well. It depends on that where you want to set it up. But this flow will be there, that data flows in. You develop the model and you deploy the model both at these places. You can deploy it here, or you can deploy it at the gateway itself. So this is the architecture that it is evolving to be able to address this life cycle. This is the architecture that is evolving over a period of time. Now, where does it lead in AI in agriculture that we see? We see that there are a lot of aspects to it. And these aspects are typically looked at from that standpoint that we see from censored, hard, soft IoT platforms and AI for soft sensors. Even sensors are basically algorithms. It has not sensors which are physically prone. It has algorithms in it to be able to establish or calibrate a measurement that you are doing. So for soil conditioning, monitoring, irrigation requirement, precision agriculture, this is one science that we see. Then there is goes into drones and CCTVs and thermal imagery, which we have seen canal surveillance, yield prediction, vegetation damage assessment, pesticide control. This becomes another element to that. Machine learning and deep learning, specifically RNN based models. We have seen that canal automation, water demand forecasting, gate operations becomes extremely critical. Wherever you are trying to do certain kind of future estimations, I think neural network had got its challenges of not being able to predict multiple periods in advance. And RNN actually has given you the flexibility to do that. And therefore, these techniques are becoming much more relevant to be able to look at it. Then other modeling techniques are very, very important, like support vector data descriptions and all are very, very important for predicting maintenance of tillers, tractors, and irrigation pumps and all those things. we see a lot of these objects. Then livestock counting, tracking and tracing, body condition identification is becoming a part of object detection, video analytics, and then natural. And here we have done, in Netherlands, we have done one exercise where it was about calves being born and they die very fast, and there's a lot many calves used to die, and when they are inside, the movement of the tail of the cow actually tells what condition it is. And we have been doing this IoT based platform to understand this behavior of all the deaths that are occurring and monitoring these setups and trying to get intelligence out of it real time, where there is some kind of a treatment that needs to be done, for the cows that are there who are on the stage of delivery and different stages of delivery as well. So there is application. There is application of facial recognition. Facial recognition, we thought that it is applicable to human, but it is equally applicable to animals. From a livestock counting point of view, there are a lot of advancements that is happening as far as facial recognition for cows, buffaloes, and you name it. There are multiple of these setups that are happening. And then these are chatbots for farmers, advising and engineering setups where we want to advise any maintenance requirement and all. To just give you a perspective of that, this is not related to the agriculture science per se, but if you look at it from a traffic rules violation system, there are huge amount of data that is available today of CCTV videos, right? All the CCTVs there are huge amount of data that is there. Now these videos are frames per second. You have load frames into that. You apply deep learning model. You generate a scoring element, and you have real-time videos flowing in, and you score images, and then there are different violations that you can detect. It's the same principle for all the CCTV based applications. Now if you look at it, this is one of the things that we are doing in Rajasthan, and including wildlife surveillance. So you see that these are raw feeds coming from the traffic exchange from CCTV. This is the scoring that you do after CCTV surveillance, and then you want to identify how many rickshaws, how many cars, how many vehicles, how many two-wheelers, how many people, what are they evaluating, and come out with scoring elements for congestion, come out with scoring element for classification. Now look at this. Now you will be able to do that, finding out which are the auto rickshaws, and very difficult from a data quality point of view. You need to train it through the number of epochs that you do in AI. In deep learning, you need to look at epochs, and these epochs are, if you increase it, they may give you better results, they may not give you better results also. There's no guarantee. You need to auto tune these setups, and then you can find out the speed, the count, the U-turns, everything. You can identify that. And it is not development only. One needs to look at it that today I am doing innovation to be applicable, to be able to repeatable in that. And one of the things that, if suppose today that somebody wants to upload an image, farmer wants to upload an image, will it classify into a proper disease, or classify into something else? They should be able to do that. So all these image setups, like I spoke about it here, all these image setups can flow into this setup. All the disease, all the crops, whatever that it is there, it gets loaded here. Then you build the algorithm, and then you classify it. So any image that comes in, any video stream, any frames that flows into the system, it automatically gets classified into the right kind of decisioning, and then integrated with the advisory or integrated with the conversational systems that needs to be deployed for the farmers. I know that's a big challenge of literacy or understanding or language that needs to be taken up. For that, you may not overrule, or you might not completely remove the human element, but there needs to be somebody who understands that and communicates back into the system. So totally maybe advisory, partially maybe conversational, and that's the way forward that we need to look at it. So the other thing and there is a development mechanism to build this. It is not that you need to code everything. There is a mechanisms that are there to be building these capabilities. Now, when we go to other examples like irrigation and all, we see that it's a tremendous challenge. It is a challenge that thousands of kilometers long. It has got flow related issues. It has got consumption related issues. It has whole sort of issues that are there if you want to look at it. So there are pools, flow pools that are there. There are demand, there are requirement, there are allocation, there are flow controls, level controls, precision control, hydraulic delays. There are host of things that are working, and the way the control mechanisms, the controllers that operate the gate operations actually did not have the capability of deploying these kind of setups. So what we see is that if you build up a process, and this is where deep learning and RNN comes up to manage the gate, one side you are looking at accurate estimation of demand, and with soil moisture conditions being also sensed now, historical farmer demands are there in now, you will be able to find out these demand patterns much more efficiently. And then once you know that, by doing the hydraulic model, you will be able to identify the supply demand and what flow, what pressure you need to maintain, and what level when the offtake is related, what kind of offtake. So right quantity of water at the right flow rate at the right place that I need to observe. So there are many things that are there. There are large volumes of data. Even the operations of the instrument itself is solar powered. So it is not sufficient to do that, but even instruments you need to monitor. You need to find out the solar generation to be able to see that, it does not decay in such a way that when actual operation, gate operation is required, I don't have the energy to actually operate those gates. So you need to have very, very critical components. There are video surveillance there. There are sensors there. There are solar there. All these elements are required to identify or handle across these systems and for each of these subsystems. So there is large set of information that flows, and AI and deep learning provides this capability. Another example that we are doing in Australia is connected farm equipments. This was came up with farmers' need of advisory services based on usage of their equipments. It could be pumps, it could be tractors, it could be tillers, it could be sowing machines, any of these setups that are there. They wanted to identify that. So we created this network with CAN and OBD2 devices based network with streaming analytics that will flow and provide them the capability of predictive maintenance, alert management, early warning, and root cause. Now this may require collaboration with other people who are manufacturers of that or who have domain expertise to do that, because any equipment, if you look at it, it segregates into hydraulics, it segregates into transmission, it segregates into engine, and it segregates into the frame and a vibration. If you classify that, it's much easier to understand an equipment. But if you go by the size of it and the tonnage of it, it becomes complex, from a battery operated vehicle to large tractors and heavy machineries. So if you keep it simple, things will become simple in that. And then when you deploy this, AI and ML will be able to provide you multiple capabilities of knowing when the transmission issues are there, when the farmer should be taking up, is the fleet ready for the farmer, what kind of usage is this, what kind of fuel consumption they are taking, relate it with your yield, relate it with the crop, and then the insights kind of explodes that you can handle. Data is there, agriculture application, huge amount of data is involved. It's a question of identifying the use cases and leveraging the data and the techniques that we look at. So these are some of the value props that we had looked at it from the time frame. Then there are other applications of forecasting and all which requires, this is an example of recurrent neural network, how it is how it is able to learn from its hidden layers itself and give the hidden layers output to the other setup. So that is we are seeing a lot of capabilities in that, and integrating with multiple setups. There you can create models, different models are there, you can create it and forecast future values, which has got its own strength from an improvement of accuracy standpoint. What you are estimating today for 2 years, 3 years, or with the classical ARIMA model or UCM model or any kind of regression models, may go and see a tremendous improvement when you look at an RNN network. We don't know. It depends on the use cases, and it depends. But we see that there are a lot of we in solar generation forecasting, including cloud cover, whatever you say, if you train the model, we got accuracy. I think it was a MAP of 97% that we did for 1 week ahead and 2 weeks ahead, and it was 95% when we did a longer time. So you will get huge amount of benefits that are there from a recurrent neural network point of view. Then there are deep learning mechanisms where we are doing it, utilities, electricity utilities, specifically transmission network, where they want to monitor vegetation, thickness of vegetation. Now, thickness of vegetation comes into, in a way of laying transmission lines and maintaining it. Now, understanding vegetation is extremely important in the right-of-way corridor. And this you can apply to crop patterns, this you can apply to over the period of time, how they are developing, what will be the yield relation of the crop behavior. If you take it from a drone, you can link it with the yield pattern, how much it will lead future. Everything can be identified that, and we are working with many Department of Agriculture to extend this kit. Now, what essentially it looks at, it looks at converting this into data, and it applies a toolkit that are there from convolutional neural networks and autoencoders, and all those capabilities are applied to be able to detect this. Now, the advantage that we see here from an AI standpoint is classical programming actually required input data, which is correct for both. It required an algorithm, very specific algorithm to be built to that, and then the output data answers that it gives that. But in an AI setup, what it is just reversed, that you need input data, you need the output data answers, what output data that you want, what answers that you want out of that, and it builds its algorithms by itself. Okay, so that's the kind of reduction in pre-processing capabilities that these deep learning setups are there, and there are tools and techniques to be able to compare it. It is not only my model is better than your model, but out of 20 models, which model is better, and why should I choose that? It is as simple as that. I don't know whether gradient boosting would be better than random forest model, or if you look at it, AI failed miserably in the World Cup, right? Have you followed that? Some predicted Brazil, some predicted France, some predicted Spain, and some predicted Germany, and all three were not there in the finals. Now, do you want to blame it to AI? There was a group of people who said AI failed, but there is actually not correct, because the approach that they took is not dynamic enough to be able to provide the inputs that are required as the stage flows, because obviously your predictions needs to flow depending upon the results that are there. So these kind of thinking also needs to be looked at from a point of view that these algorithms over a period of time need to run. It is not that one model that I built 5 years back holds good today. It will change over a period of time. So new set of images, new set of videos, new set of structured data will always provide these signs to be able to build that. And earlier we used to think that neural networks do not give, it's a black box. Today we know that factors that are significant. Today we can find out the factors that are significant for that. So there are tools and techniques that are there that can provide these capabilities into it. And I just want to end by that we have certain core setups that are there. So from machine learning, natural language, computer vision, and forecasting and optimization. But we should not forget the data management that is required. We should not forget the visualization that is required, the decision support that is required, as rightly brought out in the earlier session, and the deployment of it, because that's the crux that we need to look at. And streaming AI is another important element that we need to consider when we are talking about specifically drones and images. And this is where innovation is coming up, that today if you see my phones and all, immediately you can sense it, and you can see that it plots the bounds of my face and all. Going forward, even for whatever images you are taking, the AI will get translated into those devices itself. Whether it is being used as farm equipment, that's separate. The objects could be different, but that's the innovation that will fuel this, and it is extremely critical for this particular subject. Thank you very much.
Thank you, Dr. Dwivedi, and we'll take this discussion later on. Now, may I invite the next presenter, Dr. Karunesh Arora. Dr. Karunesh Arora, he is from CDEC Noida. And already CDEC is a pioneer worker as far as AI is concerned. So he is going to discuss on the natural language processing in agriculture scenarios and challenges. So I invite Dr. Arora.
Thank you for giving this opportunity to present our effort in the natural language processing. Though we have not done much in the agriculture domain, but some of the things which I have done in the NLP domain and what are the complexities involved, that I'll go through my presentation. The outline of my presentation is like this. First, we'll look at the India and language diversity, agriculture community and their linguistic needs, global NLP, agriculture scenario, AI versus NLP, major NLP problems, modules, resources needed, traditional and changing techniques, challenges ahead, and some of the things we have done in the NLP efforts in the terms of agriculture domain. We go by the 8th schedule of Constitution of India, there are 22 languages which are the officially designated languages. And as per the census of 2011, it says that 30 languages are there which are spoken by more than 1 million persons, and 122 languages are there which are spoken by at least 10,000 people, and total we have almost 1599, almost 1600 languages. Most of them are dialects restricted to the specific region, and many of them are on the verge of extinction because there are not many number of speakers left for those. And nearly 44% of the India speaks Hindi. That is, we can say, the major language of India, which happens to the official language of the in official domains also. And AI, as we have been listening since morning, it's in simple terms we can say that intelligence demonstrated by machines. AI is a research. It's defined in the study of intelligent agents, any device that is perceives from its environments and exhibits through the maximization of its chances of successful achieving its goals. Some common applications of AI which we see daily in different applications, though we don't notice many of them. One is the Google Maps. It tells everyone is aware of that, and everyone might be using that on daily basis. Ride sharing in Uber, autopilot in commercial flights. This has been existing since long. Face recognition as Dr. Dwivedi has also told about this in the Facebook, photo upload, face unlock feature in the mobiles, speech and search and recommendations on the online shopping like Amazon, and many more. And some of the common applications in the agriculture, though Dr. Dwivedi has told many applications, some of the things which I could Google it and found that these are some of the applications like AI-based transfer learning, image-based cassava disease detection. This was being successfully used in Tanzania. Drones are being used for monitoring, spraying and efficient field analysis. Nature Sweet company has used AI to monitor tomatoes and their growth pattern, and they have shown that if we use those learnings, and then growth can be improved. And there are others like AgVoice. They use NLP toolkit that detects soil fungal disease and prompts in the natural language what actions to be taken. And in India also some work is being started with the Microsoft that with the Karnataka government they'll be doing for agriculture commodity price forecasting model and weather forecasting and many more. When we talk about the agriculture, we see that what the actual farmer is looking for, what types of information he is looking for. So majorly there are many more. Some of the things which I have listed down. One is the weather forecast, crop related query, as Dr. Dwivedi has also pointed out that AI based agents can be, chatbots can be there which can answer the queries, These can be related to seeds, methods, season, fertilizer, diseases, insecticides, insurance, government schemes, subsidies, water management, irrigation, equipment, animal husbandry, and many more. That depends on the activities and many other factors. And what are the current sources from where these informations are being gathered? Newspapers is a common source, TV, other farmers' colleague. That this is our habit also. When we even move on the road, we believe asking the person next that what is the way. Now though things this are changing, that we are using Google Maps and other things. Radios, agriculture exhibitions, government offices, and now the WhatsApp and other platforms of the mobile. When we see that agriculture community and their linguistic needs, they want information in their own language, their native language. Second, if not available, then in Hindi, and then least they prefer English, because as we go by the data, almost 10% of the population is conversant, working and talking in English. When we say agriculture, NLP in the agriculture domain, there are some globally known efforts which are there, like AgroNLP project management. They collect different data, and it is being implemented at EU in 18 funded projects. And solutions for the data interoperability problems and developing data products in agriculture domain. Similarly, others are the AgroNLP, animal disease surveillance, terminology extraction for agriculture domain, big data for agriculture, and big biodiversity. I'll not go in those details because you might be knowing better than me, because these are the field related efforts. When we talk about the NLP combines AI with the computational linguistics and computer science to process the human natural language and speech. So it sits at the intersection of computer science, artificial intelligence, and computational linguistics, you can say. If we go by the current applications of NLP, Tactica report 2017 says that AI market growth from $136 million in 2016 will go up to $5.4 billion in 2025. This is because of the fact that we are a multilingual country and we need data in our own language. Yesterday there was a program at FICCI, and they were discussing that the rate of there are more than almost 430 million internet users at current situation, and out of that 256 million users prefer to use their native language or regional language to surf the internet to fetch the information. And the growth of that searching in their native language is increasing at the phenomenal rate of 18% per annum, while in English it is almost 3%. So this clearly shows that what is the demand, why it is needed that we should have the natural language interfaces for all the application, and specifically in the field of agriculture. In the NLP, if we see the current application and future possibilities, we look at the different sectors. One is a customer assistance. There are some of the successful cases like Nina, which is of the for AI-based speech agent, which helps the customers in the banking sector. This experiment they have performed, and they have observed that it is quite successful. In the travel assistance, we are also partner of this initiative. It's called U-Star. It is the universal speech-to-speech translation in international languages, and there are around 30 countries involved, and as many as almost 36 languages are there, and they have this is being developed for though a smaller domain, that is the travel related information query. In the automobile sector also, to enable the driver to access the apps through the voice based maps and others. And then in the healthcare, to facilitate conversation between the patient and a doctor, summarization of health records, understanding medical images and others. And personal virtual assistants, we all might be seeing on the TV that Alexa, Bixby, Google Assistant and Siri. Another successful experiment has been done by the Fujitsu. They have developed this wearable speech-to-speech translation unit, and because the doctors and all that, their hands are quite busy in performing operations and the other things, and so they want that it should be hands-free, and this is being tested in the healthcare situations with in the Japan. When we talk about the NLP, what types of problems are there, what makes it difficult, and what are the different areas that we look at. Information extraction is one of the area, information retrieval as well as arranging that in a legible manner is the information extraction. Machine translation, question answering, summarization, text classification, speech recognition, synthesis, OCR, optical characterization, optical handwriting recognitions, and many more. Language identification is another problem. If we see that last 3 sentences, though they are using the same script, but they belong to different sets of the languages, Hindi, Marathi and Nepali. This becomes even more complex when we come to the spoken form. And Konkani language itself is written in 5 different scripts, though Devanagari is the official script. Another area is the semantic text similarity, which is to measure that how similar those 2 texts are. Whether the car and bus are more similar and car and fuel are related. We cannot say that they are exactly similar. Sentiment analysis, as Madam has already talked in the morning recommender system, how to analyze the different sentiments about that. This has been used in the retail segment, but now this is being used for another segments and in different schemes of what are the different responses for the government schemes in those areas. Some major NLP submodules, if we would like to, what makes it difficult. One of the problem when we talk about the machine translation or some other domain, then we see a word which is seen in one form, though it appears as a one form, but it may appear as different forms like go, going, went and other different forms are there. So one comes, this is one of the solution, that is lemmatization is a process of reducing a group of words into one lemma form, that we need to map those as belonging to one set of the words. Like beautiful and beautifully are lemmatized to as beautiful and beautifully respectively, and while the go, better and best need to be lemmatized to the good. The another way of performing this in a simpler way is using the stemming. Like beautiful, beautifully, as those are being converted by stripping some of the characters, and beauty is taken out, and similarly good, better and best will be stemmed to the good, better, best similarly. Respectively, but this cannot be a simple problem, because when we come to the different languages like Hindi, ladka, ladki, if we follow the similar approach, then they fall into the ladak, which cannot be the proper stem for in this scenario. Named entity recognition, though it seems a simple problem, but it's a quite difficult task in terms of machine translation and information extraction. Like we need to identify that role that identity that a word is playing. Like John of Apple Incorporation traveled to Sydney on 7th December. Here John is categorized as a person, while the Apple needs to be categorized as an organization. This becomes there are some Q factors when we talk about the English, because we see that there is a capitalization which facilitates identification whether it's a proper noun or not, but it's not that simple in terms of Indian languages. When we say simple sentence, puja ne puja ki, so there is no clue that where the first puja is the name of the person while the second is not. This is for activity. Multi-word expressions, that's also a bottleneck when we come when it comes to the, in terms of the machine translation and information extraction. Like we need to, this needs to be identified as it together, by and large, ad hoc, clock tower, because if they are, that's why sometimes we see the translations done by the Google are not, sometimes we find that translation is quite appropriate, but at many times we find that it's not closer to what we expect. There are different sets of problems associated behind that makes it so difficult, and this is one of the case, like multi-word expressions, idioms and different expressions, proverbial expressions, are another bottlenecks in this field. Even in the terms of Ministry of Agriculture and Family Welfare, this total term should be recognized as one term and should be translated as a single unit. So different techniques have been applied to identify these. Word sense disambiguation, like we see different, just two examples where the plant, simple word plant is coming in two different senses. So this makes it difficult that how do we identify where it's playing what role. Part of speech tagging, this is one of the things that how do we identify the word, what role it is playing in linguistic terms. One sentence we see like Lohan killed the snake with a stick. The output is to be converted into the different syntactic tags. So different models have been applied, HMM based, CRF based, that we have already. This is a more or less solved problem, and about 95% accuracy is achieved in that. Syntactic parsing, this is another, I'm talking about the different modules which are working at the back when we come to, when it comes to the NLP tasks. Syntactic parsing is to analyze a sentence in terms of grammatical constituents, identifying different part speech, not only the part speech, but identifying the different syntactic relation in between them. Here we see one sentence where we find that the white cat, this whole has to be identified as a one NP chunk, is a whole noun phrase chunk. Similarly, different cases are there. We have seen that that makes it difficult to parse a sentence. And when it comes to the, when we transfer to a different language, the order itself becomes quite difficult, different in the different language. When we talk about the English, we follow the SVO order, subject, verb and object. While when we talk about the Indian languages, it has to be in the other way around, it has to be SOV, that word has to be moved at the end of the sentence. Anaphora resolution is another thing, like John telephoned Bill, he had lost the laptop. These are the two different sentences. So how do we identify that he belongs, he is referring to the John. Similarly, when we talk about the last sentence, we see the last sentence, will it rain today? This one sentence. And when we talk about the, when we say the what about tomorrow, a normal person will understand that the first sentence and second sentence are related. But it becomes quite difficult when we say when the words, both sentences are treated separately. The complexities involved are due to the ambiguity in the language. We see the phonetic ambiguity. A simple, there are three words, right, and right. Those are spoken similarly but are written differently. So similarly, lexical words can appear in two other different, can be a verb, can be a auxiliary verb, sometimes it can be a noun form also. So these are to be identified. Structural similar ambiguity, I saw the man with a telescope. So whether I saw the man with telescope, the telescope was being used by me, or I saw the man who was carrying a telescope. So these are the different ambiguities which make it difficult for a translation and other task in the NLP. Semantic level, that dish can be different flavors. And one of the problems we worked with the EPF, that is the Employees Provident Fund organization, that they were facing one problem, that when the person moves from one organization to another, they were having different PF accounts and they had written their names differently. So how do they map that to one single entity, whether those are belonging or not? Like see the example last, Anuj Kumar Saxena is written in a different ways. So NLP has to identify that these are the different, though being differently, looking differently, they has to be mapped to one. And different levels of analysis and knowledge are to be used. One is the morphology level, which talks about how the words and different flavors. Syntax, as we see in how the words are related in linguistic terms. Semantics, what meanings or contextual meanings they carry. Discourse, when we go beyond the one sentence. Pragmatics, even when we talk about a paragraph or even bigger unit. And world knowledge. Different data sources which are required to build different models for solving these component problems. Annotated corpus, that we have been listening in the morning also. Huge annotated corpus is required. Lexical database, parallel corpus for achieving the machine translation. Monolingual corpus for building language models. Word nets for relating different words. Speech corpus for building ASR and TTS. When we have a look at the traditional way of doing machine translation and the current way how it is changing. Previously it was rule based and now it's changing to data driven. There are different advantages and different component modules in the rule based. Like one is the analysis, transfer and then generation. We need to analyze, then we need to transfer to different language and then it needs to be converted into the different language. Different resources needed: source parser, set of transfer rules, translation, lexicon, target language generator. We look at a typical diagram, workflow architecture of a transfer based MT. Analysis side, we have the lexical, morphological analyzers, named entity recognitions, and the transfer which takes to one language to another, and synthesis when we need to generate in the target language in the so that it can be conveyed in the understandable fashion. There are different pros and cons. Then comes the statistical. Then came the statistical machine translation technique. The genesis can be understood like can be taken from the Rosetta Stone. This stone was found in 1799. It had inscribed 3 languages, and at that time ancient Greek was unknown. So because these were the parallel texts, one could relate that with the different words together. And this is the basis for statistical machine translation. This I will not go in the details because of the lack of the time. And challenges ahead is the social media, handling social media languages, slangs, language context switching, truly conversational assistants, speech production with intonation variations, domain specific translation, understanding sarcastic language. Here are some of the NLP efforts which CDEC has developed solution with the consortium fashion. One is the Hindi to Punjabi machine translation system. These have been utilized by the NIUS for translating the educational material from Hindi to Punjabi, and Vikaspedia for Hindi to Punjabi as well as English to Telugu. This deals with the text with the different domains: agriculture, health, educational, social, welfare and energy. These are the different screens which shows the different applications which have been used. There is one application for agriculture commodity price information, and this has been, one can make use of that through toll-free number, as well as a speech-based recognition system is there for Bangla, for answering different mandi related price information. These can be downloaded from the app. And we are part of a USTAR consortium, which is 36. We involves 36 institutions from 32 countries and supports 30 languages. And we are looking after for the Hindi and Bangla part of that. There are 3 components for S2S translation. One is the speech, as one can understand speech recognition, then machine translation, and followed by the speech synthesis. There is one mission from the Ministry of IT called TDIL, Technology Development in Indian Languages, and these tools in different forms are available. Information and these tools are available from TDIL data center. And we will be working soon with ICAR on a project which is the dispersal of agriculture information using the translation service in the local language, and we'll be working with ISRI in this field, where the machine translation systems which we have developed will be customized for agriculture domain. This is the upcoming conference. Just wanted to share this information. Is coming up in the month end. That will be under spoken language workshop technology for under-resourced languages. This will be held in Gurgaon, and these are some of the references. Thank you.
Thank you, Dr. Dwivedi and Dr. Arora for a very nice presentation. And before I give my final comments, do you have any question? Yes, Sangwan.
Sir, how many languages at a time we can have simultaneously? Say, for example, we have information about farmers in one language, and I extract that language in 10 languages, different times. Because in India, that farmer helpline works. In India, we are divided into 8 zones, so 8 languages are available.
Sir.
If you call from Punjab, they'll talk in Punjabi. If you talk from North India, Haryana, they'll talk in Hindi. So how many languages? And second aspect is, if we have information for farmers, say 1,000 pages, so why we translate them? We have all the time 8 translations available, 8,000 pages, and anybody can extract this information in the language he or she understands. This is one part of it. Second part, the translation, because the specificity, I speak 8 languages at present, 4 Indian, 4 foreign. Some of the languages you cannot translate into other language. For example, Russian, if you translate it to English, you lose 50% both ways. But if you translate Russian into Hindi, 100% you translate. But both these languages belong to the Indo-European group of languages. So it is extremely difficult. Then in the language, word you can translate. There is no absolutely no ambiguity about it. But sense you lose, and it becomes nonsense in the language. So how you deal? Somebody in the morning was emphasizing that artificial intelligence is more than intelligent, but it is less than intelligent. Artificial intelligence cannot think. It can do only what exercises for which you have given the input, what you have to spell out. Thank you.
As you have rightly pointed out, that machine translation cannot be perfect. It has a long way to go. Though we have seen tremendous progress, as you might have been seen, looked at the Google and other translation systems, the way they were generating the output a few years back before, and the way they are producing today, there is a lot of improvement in that. And the other thing which you wanted to, you were asking about the multiple languages. There, like in CDAC, we have been working like for 7-8 languages, where the system is able to translate in certain domain. I cannot say, I'll not say that it is 100% correct or it will be perfect translation in those domains. But when we see to understand the meaning, they are able to understand to some extent. We can say they are not fully correct, there has to be one human loop. It has to be human related, human character, because we can say that translation systems which are in the stage today, we cannot directly believe the translations which is generated automatically, but it can certainly enhance the productivity of the translators. So we can generate the person who was translating say 500 words in a day will be able to translate say 1000 words or even more with the translation systems if they are customized for a particular domain. Like we will be working soon on a project with the Ministry of HRD. You might have heard the initiative called the Swayam. It is nothing but the e-learning platform where the number of e-learning courses are being uploaded, and these are for different engineering from from humanities to engineering domain. And government wants that these should be available in the 10 Indian languages, at least in the form of subtitling. This should be done. So we are part of we are joining that initiative where the combination of AI and human will be used, like the machine translation system along with the human in the loop, translator in loop, will be used for translating those documents. You mean to say that you mean to say that those need to be recorded e-learning courses?
So no problem, no mistake, nothing, and that is easier. You are spending huge money, lakhs of rupees, translating that system. I don't think it is making it viable.
It's not scalable, as someone has rightly pointed out. There are almost 2,700 courses. So how long will it take to translate and validate through a human? It's a better way that, or we have to recreate. If a lecture is created in Hindi, then it has to be done re-recorded for all different languages. And if it is subtitling is available, then at least person will be able to understand by looking at the subtitles, and in the if it is in the form of subtitle as well as in the textual format. So it is that is one of the things that it is scalable. And
Any more question? Yes, please. Dr. Dwivedi.
So there are many use cases in livestock identification. Right one? Yeah, you can hear me now? So there are many applications in livestock identification, and all these specifically entails identifying unique objects. You know, when you look at the facial recognition part of it, what it is important to look at unique objects that you track. If you want to track a particular animal, then it has to be tracked on a unique ID, and this has to be over the activities. If you want to look at the activities, I will tell you the wildlife surveillance that we are doing in the state of Rajasthan is that you need to identify the movement of the wild animals in the forest over a period of time, and also look at their behaviors, where they aggregate, where they mate, what they do, what are the activities, where disease or any kind of diseases are there in any part of setup. And for this to be able to know it, we need to identify each and every individual, that this is the same animal which is moving. You know, today is moving there, tomorrow is moving there, day after tomorrow is moving here. So I need to track this over multiple frames. So if you look at CCTV surveillance, there are around 40, 50, 100 CCTV surveillance that is coming up. So it will move out from one frame, one CCTV view, and move into the another CCTV view, right? It depends on how you are setting up and how you are triangulating and what heights you are. So there are a lot of mechanisms around that. So if you want to do that, like in one of the cases that we did on the cow part, where calves were born dead, and we wanted to identify, and this is a very big phenomena for that country, and they wanted to identify what kind of medication, what kind of treatment should be done, and how do we recognize that it is susceptible now, much before. So those elements has to be tracked from the animal condition. That multiple animal conditions are monitored from the time they conceive to the time calf is born, and then born dead or born alive or born healthy. So this entire thing is tracked. The images, the frames of these are tracked over a period of time with the unique identification of the animal, and then classified as to which kind of parameter, the tail movement that we see. A particular type of tail movement indicates that it would have a high correlation with a calf being born dead. So that is what is extracted down. You cannot put sensors on tails, right? You cannot put sensors on tails. You need to have image based analysis and image for that portion of the all the animal. So there are many things to that. It's not that video means I have a camera so I have done with it. So to be able to arrive at the object of interest or the area of interest, that's where you crop the images on real time, and then you classify it, and then you look at the scoring patterns, and because real time images keeps flowing in, you develop the AI model and you deploy it as the frames pass by. So frames keep coming, video streams keep coming and hitting the model, and then it will tell you whether it is showing the same pattern or not. So that's how we are doing that for the livestock. How? So there are many ways to look at it. I mean, one is obviously images that we take over a period of time. So we take frequency of images. If you have multiple images to be done at the time of setup, you take that activity. You have drones monitoring it, so you have drones where you can track these elements. You have cameras with that. You have human setups with that. There are multiple data points that are there. There's no one way that you can monitor these kind of setups. So multiple images, and there could be images flowing in. There could be videos. You need to integrate all these systems to be able to identify.
I think you can discuss during tea time. Let us. Any more questions? Very quickly, last.
Sir, I have a question to Puri sir. Sir, you have shown that in the past you are using online streaming learning mechanisms. There was one slide mentioning that. Can you please explain how learning is happening online?
So there are two aspects to it. One is when you develop a model in AI or in machine or an ML or a deep learning, it's a model like a typical, like in classical setup, you used to have a score node, you used to have a score node, you have to score, and you need to score fresh data, right, to classify it or to arrive at it. Similarly, in ML and AI, you will develop these kind of capabilities, these components. And these components are deployed on the real-time data, because these are, either scored. Every frame has to be scored. Every object has to be scored. Every new real-time data that flows in has to be scored. So this goes and sits in the real-time data flow, or it could be a camera, it could be a thermal imagery, it could be a video, it could be images that you're taking, and it flows. Or it could reside. Suppose you are uploading an image, then it could reside it at that unit itself. So you can deploy that on a real-time streaming setup. That is one cycle. The other cycle is that when you want to do streaming AI, without building the enterprise model, you want to learn, there are multiple aspects to it. One is, if you are having real-time data flowing in, I don't have the luxury to monitor trends. Real-time data flows in, that is fine, but I cannot monitor trends. I will be deploying, what I'm interested is knowing patterns. So the patterns is the streaming cluster. So how will you identify streaming clusters? Real-time pattern evolution over a period, not one-time classification that you want, one-time clustering or segmentation that you do, but over a period of time, as real-time data flows in, what's the cluster formation that is coming up? That is streaming segmentation. If you want to build models, real-time models, then it has to identify the relationship on real-time through auto-tuning features. So we have taken all these capabilities into the streaming. So streaming support vector machine, streaming, support vector data description, streaming regression, everything has gone into the streaming side, because when you start using IoT, suppose you are doing predictive maintenance of tractors and you have, agriculture scientists and farm equipment specialists who are doing and trying to deliver, and the end result is an advisory system or a conversation system which involves NLU and NLI to be delivered at the farmers. You need to score these elements on real time, because today you want to advise on whether a transmission issue is there, whether it's a hydraulic issue, whether it's a vibration issue which may lead to breakdown, and therefore you will miss some of the days, productivity days. You need to deploy this on the streaming engine. So all these analytical components has been, a mechanism has been built to analyze real-time data. As the real-time data flows in, you will be able to build that. And also, whatever you are building in, like suppose you are building image classification models, that image classification model should reside the moment he sends anything or you upload it, it should immediately say what disease is there. It is not rule-based, because rule-based means you are going into feature extraction. Like Professor Reddy was mentioning about, there are 8 questions. That is one way of looking at it, where you are extracting features and then you are classifying it and then you are modeling it. But to reduce that, to reduce the pre-processing time and the errors and all, the raw information that you have, if I am able to derive intelligence out of it and properly classify, that's where deep learning is coming up. And that's how we look at it.
Thank you, Dr. Dwivedi, and thank you all for your patience hearing. And what I could see here, it's really not only machine learning and deep learning, but it's a big learning for all of us. And what I could see here, that Dr. Dwivedi has given a new dimension of the role of analytics, which plays a very important role as far as AI is concerned. So it was a very interesting one. The integration and integration part and enterprise, capabilities of analytics, because nowadays huge data is there. So a layer of the data and how to bridge up those, gaps, and bringing all multidimensional data with the full capabilities and capacity and its application in different directions and dimensions of the agriculture. So with this, and the second presentation by Dr. Arora, it was also really very, very interesting as far as India is concerned, where a large number of languages are there. So many, that ELP he mentioned about their limitations, the constraints, and how they are working. I remember 40 years back when we started, and I remember the day when there was a topic for the debate, what will be the role of computer in agriculture, 40 years back. Today, I was also one of the participants in that debate, and today what I could see, in coming time, within 2 or 3 years, this AI is going to dictate us. Without AI, will not live, whether we agree or not agree. You see the way it is moving, the power of computing, it is moving. Certainly, it is going to dictate all of us. So with this, I compliment and congratulate both of the speakers, and I request all of you give a big hand for them. So this is and here we'll stop. And certainly this entire deliberation from yesterday, I have seen, we are going to bring really good recommendations, and based on these recommendations, what as a person sitting at the headquarters, we want a clear-cut road map what to do, how to do now. Many people from last many years we are doing in different names. And now it is a high time to come together, to work with in the public-private partnership mode, and to bring a teamwork. So that will be one of the recommendations, to come with the private sector to public sector, and let us have a teamwork. And also we have to focus an end-to-end solution. We are more concerned about our research, development of various applications, but we are little bit slack as far as the end-to-end solution is concerned. And a small industry, they are giving only one end-to-end solution, and it becomes a hot cake. So this is the high time to bring end-to-end solution as far as agriculture is concerned. Thank you everyone. Thank you the organizers for giving me the opportunity. I express my sincere thanks to the reporter, which job is really very, very difficult to record each and every word. Thanks to all my speakers and program coordinators. Thank you very much.
Thank you so much.
Thank you, sir. There's an announcement. The tea will be after the concluding session, but we'll break for 5 minutes before we start with the concluding session. And before that, I would request Dr. Pandey to facilitate the speakers with the mementos. Sir, come here. I would request Director ISRI, Dr. Bhar, to facilitate Dr. P.S. Pandey.